All right, so 8.1.2 is there a shortcut? Anytime anybody ever asks this question, it's usually the answer is yes. Okay, so yes, short answer. So factoring with generic rectangles. Since mathematics is often described as a study of patterns, it is not surprising that generic rectangles have many patterns. And we saw one important pattern in the area model for factoring, that the diagonals multiply to the same product. And we did that was in the previous video, where here we have our area model, and when you multiply diagonals, this answer here and this answer right here, if you were to multiply them, they are the same. Those are the same. And so we're going to continue using these patterns as we develop a method to factor trinomial expressions, binomial 2, trinomial 3, etc. Don't worry about it. It's a good thing. And anyway, so we're going to continue factoring this so we don't have to keep building things with algebra tiles to try to figure this out. And you've actually been doing enough. You've been doing some of these types of problems before. And it's going to bring up something we've all used before, which is the diamond problems. So the diamond problems and the generic rectangles, they're related. So let's get into it. So we're going to examine this rectangle here. Here's our rectangle. Does this fit the pattern for the diagonals? And so if we take this and we multiply 10x squared times 14, we're going to get an answer. And does that match up with negative 35x times negative 4? Well, we already know that negative times a negative is a positive, and x times x is x squared. So we've already got our x squared. Okay, so now the only thing is, well, 10 times 14, that's 140. So the question is, does negative 35 times negative 4 also equal 140? And so if we look at this, if we go 35, that's negative, and we multiply that times a 4, that is also negative, we get positive 140. So to make a long story short, does it fit the pattern for diagonals? Yes. Yes, it does. So when you multiply diagonals in a generic rectangle, if everything's in the right place, you get this. If something's wrong, you don't get this. So this is a way to check that the rectangle is set up correctly. This is a check. So it's a way to check it. Are these two the same? Okay, so now we're going to develop a method for factoring without algebra tiles. First, we're going to model how to factor with algebra tiles, then look for some connections within the generic rectangle that can help us with this. And so using algebra tiles, we can factor 2x squared plus 5x plus 3. And so we have to first come up with a generic rectangle. And so luckily, we already have this. It's right here. Okay, and so this is our generic rectangle of 2x squared plus 5x plus 3. And we can see here that we have 2x here, 2x squared here, then here we have 2x. Here we have 3 x's, and then up here in the top, let me grab a different color, we have 3. We have 3 right there. We have 3. And so now if we look at this, we go, okay, so in order to get 2 x's, we got to have 2 x's here. And to get 3, we know we're going to have 3 here. So I can then bring these down here, just so it's a little farther away from all the madness that's up there. And in order to get 2x squared, we need to have an x times an x. So now we have our 2x squared is fine. And to get 2, we need a 1. And then now we have it factored. And that's all it takes, is you just kind of look at what multiplies to get things. And so this could be written as, so we would have x plus 1 times 2x plus 3, and that gives us our, and since those are our factors, and since we started with the area, we had 2x squared plus 5x plus 3. We were given this, and we went and got the factors. So that's using that. And if we look at this, we can go, well, okay, so let's look inside of it too. Let's do the same thing there. 2x squared times that 2x squared times 3, and is that the same as 2x times 3x? And sure, because this is 6x squared and this is also 6x squared. And yeah. So that's done there. Now, if we go back to this first one, what could be the factors for this? Since we know that it works pretty well. Well, we got that 14. We know that 14 is 14 times 1, or 2 and 7. And 35 is 5 times 7. And 10 is 5 times 2. So if and 4 is 2 times 2. And then we can worry about the negatives in a second. So if we look at this, what we can get to is we need to have a 7. We got 7, and then we got 2, and that gets us our 14. And then if we go 5 times the 7, we get our 35. And then if we go 2 times the 5, we get 10. We need an x, and we need an x. And then let's see. If we put the negative here and a negative here, we get our negative 2 times 2x is negative 4. So this is just kind of how we can factor this out. Okay, so we get 2x minus 7 times 5x minus 2, just to kind of get some practice in. And then we've got 10x squared. 10x squared plus or minus 39x. Plus 14. And so that is now factored. And if we look at this, we've got 10x squared and the 14 are here, showing up right here. These two are right here. So we can kind of start pulling this apart and kind of looking a little deeper into where things are in this. And if we look at that also, but anyway, and so we know that the multiplication across and diagonals works and that sort of thing. So if we look at this also, we have the 2x, we have 2x squared and 3 are on the ends, and those are also diagonals too in this one as well. So they show up here. So those don't ever change when we're factoring these things. So we've already identified some things with that. So 2x squared 3, and it multiplies to 6x squared. And then somehow inside there's addition that adds up to the 5. So if we kind of look a little closer with this, these two here will add up to that 5x. So we can kind of start seeing that everything that's in this rectangle is what we need, and we just have to look somehow to figure out how does all the pieces fit together to get the factors. And that's what this is all about. So, Miguel wants to use a generic rectangle to factor 3x squared plus 10x plus 8. And he knows that 3x and 8 go into the rectangle in these locations. So they do that. So we've already established that from here, that we've got places that they go. The leading term and the end term, bottom left, top right. Or however you want to set it up. But they're diagonal. So this is that diagonal that we're talking about. Right here. Let's try to stick with the same colors. Let's see if we can't get a little. There we go. So that's that diagonal we're talking about. And we also know that that's going to multiply then to, it's going to multiply to something. And that multiplies to 24x squared. And so we also know that the other diagonal also has to multiply that. And so we know that there's some multiplication diagonally that actually ends up happening. So how are we going to use this to our advantage? Well, we also know too that these terms that come down on the green diagonal here, they have to add up to the 10x. That's where that comes in. Okay, and so we've got these two here that are multiplying, and whatever they multiply to has to also add up to 10x. And the one place that we've seen this before is in our diamond problems, where things have to add up to something, and they also multiply to something. So if we just focus on the numbers right now, we need to come up with numbers of 24 and 10. So what can we kind of come up with that's going to fit in there, that's going to actually work, that's going to add up to 10 and also still multiply, it has to multiply to 24. And so we can go, okay, well, 24, let's see, 24. 24 is, if you take 24, we can go 12 times 2, 24 times 1, 8 times 3, 6 times 4. Now, which of these add up to 10? 12 minus 2 is that. We have all positive terms, so they're both going to be positive. Okay, and so really the only option we have is 6 and 4. And so it really doesn't matter where we put these now, but we can go, and we know that this had an x, this had an x squared, so these both have to be x's. So we can just go, okay, 6x and 4x. I'm just going to do this. Hopefully we can take this. There we go. 6 and 4. And that's how we got that. So we had to get there, and now we have, so we use the diamond problem, we can figure these things out. And now all that's left is we now just have to factor it. And the only way we can get 3x is with a 3x. Okay, and then so now would have to be x there. But we're not going to be able to get the 6 with the 3 like that, so we just switch them. No big deals. 3x times x, 3 times 2 is 6, and then if we have 4, 2 goes to the 8, so that would have to be a 4 because that's a 1x there. And we are done with this, and that's been factored. So what we just did was we said, okay, 3x squared plus 10x plus 8, that factors down to x plus 2 times 3x plus 4. So now we can use, so we're using some things that we've used before to do something new. And that's kind of dope. So once again, we have this one is here. And then we have our second factor here. And so now that's factored. Okay, so let's look at it again. So Kelly wants to find a shortcut to factor 2x squared plus 7x plus 6, and she knows that 2x and 6 go into the rectangle shown. And so, good. So these are going to be, that's right there. Okay, and that's just going to be our 12x squared. Okay, so what factors, what makes up, what can go to 12x that's going to add up to 7? Is really all we have to look at. And so again, if we go with this, adding and multiplying, okay, we know we have to have 12x squared, and it has to add up to, and I'll just put this right here, that's 7x. They have to add up to 7x. So we're multiplying to the 12x, and they have to add up to 7. Okay, and so really the only thing that adds is 7, 5 and 2, So let's just, what makes 7? 7 plus 1, 5 plus 2, 3 plus 4. And we're kind of done with that. And then you go, okay, what multiplies to 12? Well, 12, that's 6 times 2, that's 3 times 4, that's 12 times 1. And you just got to look for it and say, okay, so what's going to add up to 7? Well, 3 plus 4 is 7. So why don't we try that? 3x and 4x add up to 7x, and 3x times 4x is 12x squared. So, and they're both positive. Okay, so now we just go, all right, so now we can say, okay, so that's 3x and 4x. And now we just have to figure out what goes around it. So what could go around this if anything would? Well, we know that we got to have a x here. So we got an x and an x. Okay, and we got to have a 2, and we also have a 4. So if we go, well, 2 times that is 2x times x is 2x squared. 4 is simply going to be 2 times 2, and 2 times 3 is 6, and that's it. And then all of a sudden the puzzle pieces fit. And so what we can then say is, okay, so we've got, we were given, in purple, we were given 2x squared plus 7x plus 6 factors down to 2x plus 3 and x plus 2. And that's it. Using the diamond problems and diagonals and what things add up to something. So so there we have it. So these two add up to, these make the 7x. Those two there. Because we end up combining those as like terms. And 3 times 4 is 12. So they both multiply to it. And so now we're using some patterns and things to our advantage. And with this product and sum. So now we're going to look at this. And let's try to do it without all the lines and everything like that. So we know we got to have the 2x. We know we're going to have 2x squared here and 6 here. And we know that when we multiply those, they're going to go here. And then when we add them, they're going to add to here. Okay, and they add to the 7x. So we know that we have 7x here, and then we have 12x squared here. And we know that, again, 3 times 4. And before, we put it like that. So this time, let's put the 4x here. So 4x plus 3x is 7x and 2x squared. And 2x squared times 6, that's 12x squared. Okay, so that's where all the pieces go in. Then we add those 3x plus 4x is 7x. Good. Okay, so now we still need that 2x and that x. And then we have to have a 3 here. And 2 times 2 is 4. So now we have 2x squared plus 7x plus 6 is equal to x plus 2 times 2x plus 3. And that's been factored. And so what really ends up happening with this is it's still going to end up being the same thing. So we just factored that, and this is factored. So we got x plus 2 and 2x plus 3, and even doesn't matter where you put them. We still got x plus 2 times 2x plus 3. Piece of cake. So factoring the generic rectangle is convenient when algebra tiles are not available, because we don't always want to have to go through algebra tiles. So first, once again, these two, 6x squared and 12. Okay, and we know what they're going to multiply to. They're going to multiply to whatever this value is, and that's going to go here in the top. Okay, and so 6 times 12 is 72. let's just verify, 6 times 12, 72. Okay, so that is now 72 x squared. And then if we take these, we know it has to add, so these two are going to be like, these two are going to be like terms, so they're going to have to add to this, which is this number right here, 17x, and so we just put that in here, and we go, okay, so that's got to be 17x. And so what factors are going to add up to 17 that multiply to 72? And so this is where multiplication kind of comes in handy. 72, let's see, we got 72 times 1. We know it's 6 times 12. We also know that that's 9 times 8, I believe. Let's just check that. 9 times 8 is 72. And 9 plus 8 is 17. 9x and 8x. And so now we're done. 9x and 8x. And now what we have to do is come up with what goes around the outside of this puppy. And so let's just kind of get to it. We got a 9 and a 6, so 9 and 6 have a common factor of 3. So I'm just going to put an x here. That would mean that this one has to be 2, because 2x times 3x, and 2 times 4 is 8. And so then we got 3 times 3 is 9, and 3 times 4 is 12. Positive and positive. And now we are out. And so we've got 6x squared plus 6x squared plus 17x plus 12 factors down to 2x plus 3 times 3x plus 4. And that is now factored. Okay, so now we've got a few of these to, let's just get some practice done and see how many we have to do. And that'll take us out to the end. Okay. All right, so just looking at this, again, everything goes into the same place. We've got, that's got a 1 and that's an 18. So we know that that's x squared and that's 18. And if we multiply these, that's going to be right here, which is 18x squared. So I'm just going to I'm just going to go with the numbers at this point. And then we know that if we add these, they go here and they got to add up to 9x. So that goes here, which is 9x. So this is a 9. And what two numbers multiply to 18 and add up to 9? And you go, okay, 18 times 1, 9 times, oh, let's just start with 1 times 18, 2 times 9, 3 times 6, and I like that. 3 and 6, and here's our diamond problem. So we just have 3x and 6x. Okay, and now we just have to factor it. And we know that we're going to have an x here and an x here. Excuse me. And x times 3 is 3x, and x times 3x and 6x. So x times, that would have to be a 6. And no worries. X times 6 is 6x, x times 3 is 3x, 6 times 3 is 18, x times x is x squared. So we just say, okay, it factors down to x plus 3 times x plus 6. Factor. Okay, let's take the next one. Once again, we know where things are going to go. We got the first and the last. And then we multiply them. We get our number that goes in here, and 4 times 15 is 60 with a negative, so it's negative 60 x squared. So I'm just going to use the numbers, negative 60. Negative 60. And then we know that when we add them, we get the other diagonal, which also has to multiply to the same thing. So that's got to be at 17x. So we're going to put 17 in here. So that's 17. And one of them's got to be negative, positive, and so now we just kind of got to look at this and sort of say, okay, so we know that the largest one is negative and positive. So the largest one, we need a negative and we need a positive because it has to multiply to a negative. And so we then just start looking, okay, 15 times 4, 15 times 4 is 60, but it doesn't add up to 17. 5 and 12 would add up to 17, but we need one that's negative. We got 6 and 10. And so we just kind of keep playing with the mathematics on that. Keep going. So we got 60. What multiplies to 60? Okay, so let's start off with the 1. That's 1 times 60. That's not going to work. Then we got 2 times 30. That's not going to add to 17. Then we got 3 times 20. They're 17 apart. And so we just kind of got to keep looking at these and don't quit on it. And so we know we got a 3 and a 20, and the largest one's got to add up to positive, and we know that 20 minus 3 is 17, and 20 times negative 3 is negative 60, and so now we are golden with that. So we've got that. That's been figured out. Boom. Done. So we got to have a negative 3 times 20 will work. So we got a negative 3x and a positive 20x. And so now it's all coming together. And so now we just have to come up with what goes here and then what goes right here. And we know that we need to have an x and an x. And so now in order to get a 4 to the 20, we need a 5. Or we need a 4 times an x, 4x, 4 times 1. So I'm just going to go with 4x here, which means 4 times 5 is 20. So the bottom looks like it's done. And then now to get to a negative 3, we need to get negative 3x times x, we need a negative 3 here. And so negative 3 times 5 is 15. And I think we're good. So these factors into this factored out to 4x minus 3 times x plus 5 factored. Okay, last two. So let's see if we can get this. Okay, so we know that 4x squared, and we know that 3 plus 3, and we know that if we multiply them, they're going to give us a number, and that number is going to go here. And so that's going to be 4 times 3 is nothing more than 12. So that's 12x squared. So I'm just going to focus on the numbers, which is 12. And then we know that if we take, and then this number that's in the middle goes here, because this has to add up to that. So we've got negative 8. And since they got to add up to a negative, we need to count something that's going to be 12. So if we look at the factors of 12, we have 12. We have 12 times 1. Well, let's start off. Let's be smart and pattern about this. So we go 1 times 12, 2 times 6, 3 times 4, and I think we're good. And so what of those could come up to 8? And well, that would be negative 2 and negative 6, because the negative times negative is positive. 2 times 6 is 12. Negative, negative, positive 12, negative 6, and negative 2, negative 8. So we just go negative 6x and negative 2x. And then now we've got our rectangle. And now what we have to do then is factor it. And so we're just going to put some of these here, and we'll put some of these here. We know we need to have an x and an x every single time. And in order to go, then we have a 4 and a 2, we got a 6, we got a 3. The only way we're going to get that 3 up in the upper right-hand corner is with a 3 and a 1. And now we just got to figure out where is it going to go. So if we go 1 times 3 this way, and they have to be positives, which means somewhere there's a negative term somewhere in here. So in order to get that negative 6, we could go with a negative, let's go with 2. So if we put 2 here and 2 here, we get 2 times 2 is 4. And we have 2 times 3 is 6. 2 times negative 3 is negative 6, 2 times negative 1 is negative 2, and we're done. So now we have 2x minus 3 times 2x minus 1. And that's been factored. And so, feel good about that. All right, so now what we have to do is we got to look at this one and we say, okay, so we got 3x squared and minus 3. So we go 3x squared and minus 3. And if we multiply these, they're going to give us a number here, which goes right here in the top because we multiplied them. And so 3 times, that's negative 9x squared. 3 times negative 3 is negative 9x squared. And so then we know that this then has to come out to this one here in the middle. This middle term has to go here. And that has to be a, so we got, let's go back, negative 9, and then we got 5. So what are the factors that we can get with 9 that somehow will work out to be 5? So if we go 9, we got 1 times 9, 2, 3 times 3, and that's it. So we're kind of stuck on this because I don't see, that's it for 9. And so 3 and 3, 3 minus 3, negative 3, negative 3, it's not going to work. Doesn't matter what happens. So we got a problem. We don't know what those are. And so we can't get this, which means this is probably not a rectangle. And what I mean by that, it's not a rectangle we can make with tiles. So if you can't make a rectangle out of it that's going to work to that, then by factoring it, then we would say that this is not factorable right now. Not factorable using the area model. So this is a problem that we can't do right now, and that's okay. So that's what happens if something is not factorable. It just, you can't do it with the rectangles, so it's not going to factor nicely like the other ones did. So we just say it's not factorable for now. So, to be continued. So, not factorable. All right, that's it. So, have fun. See you online.